where the Mark II has the older type PLC when working with the 8620. So again, the Mark II can be Mark II 20 can be switched between 8610 mode and 8620, as can the 8600. But the main difference between them is the fact that this can be carried out on the fly, so it could be via a input, whereas with the Mark II you have to remove input. The multi-set unit is exactly as it says, it's for multi-set applications, so unlike the single set, which is single main, that is switchable between mains and group controller mode. The module as part of the application would be you have a single mains module, a single mains supply. You could have this with or without this the bus breaker, and then you'd have a bank of multi-set modules, which are effectively like the 8610 Mark IIs. Then you have the normal multi-mains application, whereby you'd have two loads, two mains, controlled by two mains modules, and they can then share a bank of gensets, which is essentially, when in group mode, the 8600 or the 8660 can control a back controller, another group controller. Each has control of its own breaker, and then again that it controls that bank of gensets. We then have the 8680 module, which has the 7-inch colour display. This is essentially, again, the G version of the 8620, can be switched between single set and multi-set. So what you'll notice about these new modules is wherever possible, we've kept the same pinout, which means that it should be easy to upgrade existing applications when moving from an 8610 Mark II or an 8660 Mark II up to a G series module. The only main difference between the two are, as you can see in the upper right corner, we have pins 68 to 77, which are now configurable between digital and analog inputs, which then gives you additional flexible inputs to satisfy your application. The only thing that you may need to consider is, because we've added the additional ground, you'll need to reference that ground to plant battery negative, as always with any analog input. Mark II and 8660 Mark II and the G series we've added better load demand scheme sets, but we have the spinning capacity and spinning reserve. So historically what we had was amount of sets to close the bus breaker, and then minimum number of sets. So essentially what we did there was, if you had a bank of gensets, let's just say we've got these gensets that are here on the display. So we've got has now been extended to 64 controllers on the same AMSC link, and we now have essentially two AMSCs. We've got AMSC 1 and AMSC 2. Now what happens is the group controller has two AMSCs. One AMSC for group modules and mains modules, and the GenCom over the AMSC, which that can be from any of the modules available on that bus. It can write the GenCom over the AMSC too for things like changing priorities, which this allows each section of bus to be separated into a section all of its own, and allows any part of the application to be connected and disconnected at will. And essentially what happens is you have to ensure, as the application designer, that the module knows which section of bus it's connected to. And when you ensure that you do this, that means that the module, to all intents and purposes, that the G series introduces phase locking, and then that essentially satisfies the requirement for holding the two supplies in sync for a required amount of time before closing a breaker. The multi-level front panel editor. So what we do is very much like in the old, in the 73 and 74 modules, you essentially, within the config suite software, enable the multi-level pin protected FPE. You choose the items that you want in each FPE, or whether you don't want them in FPE at all. Create yourself a pin. So these are essentially virtual switches. You have got 12 of these, and they can be accessed via the front panel, the front panel. So before I just quickly cover the new SCADA, which the G series and all the G series is can't do that.